Welcome to my channel once again. Today we are going to focus our lens on fluids and electrolytes. Introduction to fluids and electrolytes specifically. Introduction to body fluids and electrolytes. So what are body fluids? Body fluids are liquids that make up a large proportion of our body weight and are essential for maintaining life and normal body function. In a healthy adult male, 60% of water makes up our body weight. In a healthy adult female, 50% of water makes up our body weight. And then it varies. Some literature propose 55% or 50 to 55% for adult female, and for infants 70 to 80%. But other literature starts from 60 to 80 or 77 to 80. Function of body fluids. Body fluid performs several vital functions. 1. Transport of nutrients via the plasma, the liquid portion of the blood. Then oxygen via the red blood cells. Then we have removal of waste products, which is urine and sweat. They are all in liquid state, that is just fluid. Urine with assistance of the kidney, sweat with assistance of the skin. The regulation of body temperature, where blood moves with heat, help in distribution of heat throughout the body. Then we have lubrication of joints and tissue, such as the synovial fluid, which help lubricate joints. We have medium for biochemical reaction. Very simple fluid in the body serve as a polar solvent, very good for biochemical reactions. Maintenance of blood pressure and blood volume. When there is an increased fluid in the vessel, increases pressure. When it's decreased fluid in the vessel, decrease pressure. So let's look at the body fluid compartments. There are two of them. We have the intracellular fluid compartment, which is made up of the intracellular fluids. We have the extracellular fluid compartment, which is made up of the extracellular fluid. So intracellular fluid, intra means inside, cellular means cell. So these fluids are located inside the cells in our body, and they account for 2/3 of the total body fluids, and they are rich in these electrolytes: potassium, magnesium, and phosphate. Meaning inside the cell we have more potassium, magnesium, and phosphate than outside the cell. And then we have the extracellular fluids. Extra means outside, cellular means cell. So these fluids are located outside the cells, and they account for 1/3 of the total body fluids. And extracellular fluids are subdivided into three. We have the intravascular fluids. Intra means inside, vascular means vessel. So these fluids are located in the blood vessels. We have the interstitial fluids. Inter means between. So these fluids are located between our cells in our body. Then we have transcellular fluids. Trans means beyond, or through, or across. So meaning these special fluids are produced by cells, alright, and then they are transported across these cells into special cavities, or through cells they are produced and then stored in special cavities, such as the CSF, the cerebrospinal fluid, the pleural fluids which are around the lungs, then the synovial fluid which is located in joints, cavities around joints. And these extracellular fluids are rich in these electrolytes: sodium, chloride, and bicarbonate, meaning the extracellular fluid has more of sodium, chloride, and bicarbonate than inside the cell. Okay, we are done with fluids. So let's move to electrolytes. So what are electrolytes? So that's the body's electrolytes. Electrolytes are minerals in body fluids that carry an electrical charge and are essential for: 1. Nerve impulse transmission, that's sodium and potassium. Then muscle contraction, sodium can be there, as well as potassium and calcium. Then we have acid base balance like the bicarbonate. Regulation of water balance, sodium also plays a role over there. Examples of electrolytes: sodium, potassium, calcium, and chloride. Note: a positively charged electrolyte is termed as cation. A negatively charged electrolyte is termed or known as anion. Okay, so let's look at some major electrolytes and their summarized functions. So we have sodium, which is a cation, and sodium is a main electrolyte in the extracellular fluid, meaning sodium is more extracellularly than intracellularly. Then the function of sodium include water balance, blood pressure, nerve and muscle function, with a normal range or normal value of 135 to 145 milliequivalents per liter. The second, we have potassium, which is also a cation, which is the main electrolyte in the intracellular fluid, meaning potassium is more intracellularly than extracellularly. Importance of potassium: cardiac function, muscle contraction, and nerve impulses, with a normal value or range of 3.5 to 5.0 milliequivalents per liter. And third, we have calcium, which is also a cation. Calcium is important for bone and teeth formation, blood clotting, and muscle contraction, with a normal value or range of 8.5 to 10.5 milligram per deciliter. Then four, we have chloride, which is an anion which works with sodium to maintain osmotic pressure acid-base balance, with a normal value of 98 to 106 milliequivalents per liter. Sometimes this ranges varies per books or literature. And the last of my slide is bicarbonate. And then bicarbonate maintain acid-base balance, acts as a buffer with a normal value of 22 to 30 milliequivalents per liter. Note: aside milliequivalents per liter and then milligram per deciliter, which is measured for calcium, electrolyte can also be measured in millimole per liter. So when you see millimole per liter somewhere, it doesn't mean the values here are wrong, but that's a different unit of measurement. Thank you for your time. That's all for today. There are a lot of types of electrolytes out there that are not yet included in the slide, but as we move forward to the second part of the presentation under this same topic, we'll get to be exposed to them. Okay, this is all for the day. Till we meet next time.